Alright, time for solutions on homework 12. Number 1, we got it once again, a compound inequality. You solve the left side inequality, and then you solve the right one. You solve them separately. And then you graph them both on the same number line, and then you write out their answer in interval notation. We'll start with the left side. I need to choose. Alright, so your first step should be to simplify each side as much as possible. Well, on the left side, that's as simplified as it can be, and on the right side, that's as simplified as it can be. So that step's already done. Next step is figure out which side you want your variable on. I'm going to choose the left side because I can, and so I'm going to get rid of my variable on the right, which is over here. I need to get rid of negative 3x by adding 3x. What do I do to one side? I do the other. Now on the left side I got 7. Negative 4x plus 3x is negative x less than. On the right side there's no more x, and you just got negative 2. Now I need to get rid of this 7, which is in front of my, well, I need to get rid of the 7 on the front, so I need to subtract 7. What you do to one side, you do to the other. Now I got negative x less than negative 9. And you get rid of the negative by dividing by negative 9. Since I divided by a negative, I need to switch the direction for my inequality sign. And that becomes 9. And now it's time for our right side inequality. On the left side, I notice that it has a variable term but no other ones, so I'm going to choose the left side for my variable. I get it out of the right side by adding x to get rid of the negative x. What you do to one side, you do to the other. Now I got 6x greater than or equal to 6. I need to divide by 6 to get rid of it. And I got x is greater than or equal to 1. Because 6 divided by 6 is 1. So now I got this OR statement. That's going to have an effect here after we've graphed it. So I need to have x greater than 9 and x greater than 1. So I should put my 0 over here. 1, 2, 3, 5, 6, 7, 8, 9. 1, 2. Yeah, so you need, when you're graphing, you need a number line. Make sure both your points of interest are on it. Okay, if I graph my left one, I need a circle at 9. I am not going to fill it in because there's no line underneath the greater than sign, and I just need a shade which direction. Here it says x is less than 9. I mean, what am I saying? X is greater than 9, so I need a shade to the right. Shade to the right. Put an arrow there. And now I'm going to graph this guy where it says x is greater than or equal to 1. I need a circle at 1. Since there's this line here, I'm going to fill it in. And x is greater than or equal to 1, so I need shade right. Shade right. Okay, so now I got my graph done. And notice they both go to the right. That can happen, and it's okay. When you're writing your actual answer, you need to look at your statement at the start. If it's OR, then your solution is anything that got shaded at all. And so my shading starts here at 1, and it goes to the right. Over here, once you get past 9, it got double shaded, but we're not really worried about double shading, just anything got shaded at all. So it starts at 1 and keeps going to the right and never ends. So when we write our interval, it goes from 1 to infinity. Infinity is always curved, and since 1 has a closed circle, we're going to use that square bracket, and ta-da, there it is, the answer in interval notation. Alright, now we're at number 2 here. This is also a compound inequality. It is, when you see it with like something in the middle and then two less than symbols, this is always an AND compound inequality, and you can deal with it separately, split it into 2 groups. So you look at the left 2 items, that's an inequality you can solve, like so. So you write that out. and you look at the right two items to get your other inequality, which is 5x minus 2 less than 1. So now you got these down. You solve them separately. But something to notice is that when we're solving for our x, you notice how they both have this this middle part here. That means that you're going to do the exact same steps in solving for x on both sides. So if I'm going to add 2 here, I should add 2 over here. And what you do to one side of your inequality, you do the other. So on the left side here, we got negative 5 less than 5x. Right side, we got 1 plus 2, which is 3. And you got 5x. And now you just have to divide by that 5 to get x by itself. And since you do it on the right side equation, you do it on the left. So you divide by that 5. And now you got negative 1 less than x. So you got negative 1 is less than x. And, remember, this is always and. When you have this variable stuff in the middle, and then less than or greater than on the side, it's always an and compound inequality. So we're looking for x being less than 1, and, x being greater than negative 1, and x being less than 3/5. So let's put 0 down, and put negative 1 over here, and get 1, 2, 3. Okay, so now we got our number line ready to go. I'm going to graph this left one first, so put a circle at negative 1. And this says negative 1 is less than x. So x has to be numbers bigger than negative 1. So I'm going to shade to the right with that, shade right. Okay, and now I'm going to graph my right inequality. You need to put a circle at 3/5, which is a little bit more than half right there. And I'm not filling it in because there's no line. And this says x less than 3/5, so I need to shade left again. Okay, and since this is an and compound inequality, the only part that's actually part of your solution that you write your interval for is anything that got double shaded. And since the one from negative 1 goes right and the one from 3/5 goes left, the only part that got double shaded is between negative 1 and 3/5, this little section here. So our interval goes from negative 1 to 3/5. And since we have open circles, we're going to have curved brackets, and that is the end of number 2.